doing it anyway. Bing bong, it's recording. All right. You watched the videos on rotations, and you saw that the Nick Perich method of rotating shapes involves you turning a paper around. Well, in this case, I can't turn a paper around because I'm on a Chromebook. So what I'm going to do is I'm just going to draw these pictures anyway and see if I can use a little bit of common sense. Rotate triangle A, which is -1, 2, beep, beep. Let's make it bigger. A. B, which is right 5 up 5, beep, beep. And C, which is -6, -2, beep, beep. And oh yeah, this was the same triangle that I had yesterday, and it was an awful, awful, awful triangle. What I have to do is I have to rotate this 270 degrees clockwise. This is what I'm going to do. I'm going to do this one dot at a time. I don't have paper that I can spin around and manipulate and make it work. So I'm going to have to use my own common sense here. And I have plenty of it. Let's start out with -1, +2, A. I want to rotate 270 degrees clockwise, which looks like this. A will go from here to here to here and end up somewhere over there. That's what 270 means. 270s means 1 turn, 2 turns, 3 turns, and it creates a 270 degree angle. 270 degrees clockwise is 3 turns. Pretend that this red dot is the end of my pen here, and I'm asked to spin it 270 degrees. 80 degrees is going to look, or sorry, 90 degrees is going to look like that. 180 is the exact opposite, and then 270. It's also fun to think that 270s clockwise, so here it is, 270 clockwise is also the same as 90 counterclockwise. So that's what I'm going to do. That's what I'm going to do. If I were to take the ball A and throw it against 0, 0 and have it ricochet off of 0, 0 and create a 90 degree angle to the bottom left, it would look like this. This is me throwing the ball. And I'll use a different color. It ricochets at a 90 degree angle and lands there. So fun fact, -1, 2 became -2, -1. Let's do it again. Oh, that's A prime. We're calling that A prime. And some of you might be like, this is confusing. And it very well may be. And I understand that it is. And when we get together in person and we can actually do these on paper, then you may do it on paper and I won't scream at you. There's B perfectly drawn. I'm going to also create B at a 90 degree angle. So I'm going to throw B at 0, 0 and create a 90 degree angle. 5, -4 is going, I'm sorry. 5, 4 is going to bounce off and become -4, 5. C is -6, -2. So if I were to bounce C off and create a 90 degree angle, where am I going? Counterclockwise, that would land down here at 2, -6. Now, again, I realize that by doing it this way and viewing it as a ball bouncing off 0, 0, it makes the problem significantly more challenging, and I get it. You will never see me do rotations like that ever. Ever. In class, in person, you'll never see me do rotations like that, ever. However, some of you have the math brains to realize that wait, -1, 2 became -2, -1. Those numbers are almost exactly the same. And if all I have to do is just kind of flip the number and keep the one number negative, then I'm in good shape. Some of you are able to figure that out mathematically. And if you have an algebra brain, you're in good shape. If you have an art or a geometry brain, then you can visualize the rotation. Either way, no one likes rotations, and we're just going to move on. And I do have a billion trillion videos on rotations, the Nick Perich way, and the Nick Perich way is the best way. Let's see. I will be able to find the volume and surface area of three-dimensional solids. Lots and lots and lots and lots and lots of formulas. Have your series ready. I know I do. Okay. Volume and surface area. Identify three-dimensional figures. 1. A solid with all flat surfaces is called a polyhedron. Okay, a solid that is not rounded in any way, it's just a flat surface, like a die, is called a polyhedron. A sphere is not a polyhedron. A cylinder, not a polyhedron, because those have circular components. Each flat surface is called the face. The lines that make up the edges, believe it or not, are called edges, and the corners are called vertices, which is vertex plural. Okay, that is what a polyhedron is. Here's some names. A prism has a roof and a ceiling that are exactly the same, okay? And a prism has to have a polygon for a roof and a ceiling. So it has to be a square, or it has to be a rectangle, or a triangle, or it can't be a circle. That becomes the non-polyhedron. That's a non-prism. You're not allowed to be like, well, isn't a cylinder a prism? No. Cylinder is cylinder. A pyramid, you already know. A pyramid is basically a prism, but instead of it going up to a ceiling, it goes up to a point. There's only one base, but you still have a bunch of triangles on the side, and you still have some type of base on the bottom. That's a polygon, and nothing's going to be rounded. The most common ones that we'll look at in 8th grade math are the cylinder and the cone and the sphere. Okay. Those are the most common ones that we will see in 8th grade math. Cylinder, you already know what that is. Cone, if you ever had ice cream, you already know what that is. And sphere, all of you homies like to ball so hard know what a sphere is. Advanced. That's right, Camilla. Advanced. I have a sneeze that's just lingering in my nose, and it's not going away, and it's bothering me. Look at these names. Look at these names. Look at these names. These are all prisms or pyramids. If you take a look at the very one on the left, that's a triangular prism, and you might say, no, that's not a prism, sir, because it's kind of like the base and the bases are not the floor and the ceiling. It is if you tilt it up, and it has a triangular base. A rectangular prism is exactly what it sounds like, and it's exactly what you're used to. You have a length and a width and a height. It's a box. It's a cube. If you want to be a cube, it's a cube. You have a pentagonal prism. I can make a hexagonal prism. I can make a octagonal prism, which is where people fight. I can make a dodecagonal prism. Whatever I want, as long as the base and the other base, or the floor and the ceiling, are exactly the same, you have a prism. I could take prisms and turn them into pyramids by simply taking the roof and caving it into a point. And that's where we get triangular pyramid. And I can get a rectangular pyramid, or a square pyramid, and a pentagonal pyramid, or a hexagonal pyramid, or an octagonal pyramid, or anything along those lines. Do we have any questions? Good. By the way, an octagonal prism has a base that is a what? Please either type it out or unmute yourself. Please. 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 Are you guys speaking and I can't hear you? Are we doing the thing where I'm muted? Am I muted? No. Is someone speaking though, and I can't hear them? Because
Can you hear
oh,
me?
I hear Paul. Okay, we're good. Okay, no,
Okay, then
I can
good.
hear you, Paul. An octagonal prism has what for a floor and a ceiling? Think of how you can manipulate. Go ahead, Paul.
Octagons?
Say it one more time.
Octagons?
Sure, very good. Because octagonal comes from the word octagon, and that's where people fight. Determine whether the solid is a polyhedron, then identify the solid. If it's a polyhedron, name the bases, faces, edges, and vertices. In the chat, because I'm experiencing a little delay on the headphones. In the chat, is that a polyhedron, yes or no? No, says Paul. What is this? What is it? What is it? Okay, so Camilla gave me both answers. Good. If it's not a polyhedron, and then I'm supposed to identify it. So what is that?
I
didn't hear you, Paul. Say
it. I at least forgot.
It's a cylinder thing, says Camilla. It sure is. It's a cylinder thing. That's what when the cylinder goes to a party and nobody understands the cylinder goes, it's a cylinder thing. Right? No? Okay. Is that yes or no? Oh, Camilla already said it. Is this a polyhedron? Yes. Now what I have to do is identify the solid. So I don't know if that base is a square, so I'm not even going to risk it. So I will call it a rectangular prism. Excuse me. Can someone figure out what I just said?
Triangular prism?
A what prism? Not a triangular prism.
Rectangular, then?
Rectangular prism. Very good, because the bottom is a rectangle. Oh my goodness. Rectangular prism. Name the... Okay, well, I will do this without writing it out. What's the base? What's the base?
A rectangle.
A rectangle is correct. So Santi said the rectangle was the base. The bottom is the base, the floor, if you will. And what are the faces? Triangles, good. How many edges do you see? Again, the best way to describe edges is if you were to look at the room that you're in. I have a rectangular prism room. The edges would be the corner lines, the 8 says Jill. Let's find out. And somebody else. I missed who else it was. 1, 2, 3, 4, 5, 6, 7. And then the one we can't see in the back is 8. Very good. How many vertices do I have? 5 is correct. The vertices are the actual corners themselves. Oh, look at 555. That's the beginning of fake phone numbers. 1 dot, 2 dot, 3 dot, 4, 5 dot. That is such a beautiful picture. That is such a beautiful picture. Okay. Anything round makes it no longer a polyhedron. Anything that is, again, if it's not round, then you can't name the bases. Yeah, I dinged. You can't name the bases, faces, edges, or vertices. So this should make sense. What we learned the other day is a regular polygon. And a regular polygon is basically you have a shape, a two-dimensional flat shape where all the sides and all of the angles are equal. So the most common one is a square, or like a stop sign is a regular octagon because all the sides and all the angles are equal. When you turn them into three-dimensional objects, they're called regular polyhedrons, or a regular polyhedron, or plural is regular polyhedra. So when your guys are walking down the street and someone's like, bro, what did you learn today? You can be like regular polyhedra and not sound like a buffoon. There are exactly 5 types of regular polyhedrons that are called Platonic solids. Now, Platonic solids are solids that are just friends. Because, okay. These are the Platonic solids. There they are, 1, 2, 3, 4, 5. A tetrahedron. If you ever played Tetris and you're wondering why Tetris, it's because all of the pieces in Tetris are made of 4 blocks. So the word tetra comes from 4 things. Did you know that, by the way? Did you know that in Tetris? All the pieces. Ooh. A cube, also known as a hexahedron. That's a 6-sided thing. Hex means 6. The word hex is an evil thing, and 6 is an evil number. Octahedron is obvious why that is, and all the sides of an octahedron are triangles. A dodecahedron, I believe. Oh no, that's not true. A dodecahedron is 12 regular pentagonal faces, and this is a tough word. It's icosahedron. If you've ever played Dungeons and Dragons, which since this is geometry, most of you probably have. An icosahedron is that dice that you roll that has the 20 sides. At least if you've seen Stranger Things, and you've seen them play Dungeons and Dragons. Camilla, you know exactly what that means. You know exactly what that means. Because Dungeons and Dragons are for cool kids. But anyway, all the sides are equilateral triangular faces. Okay, and there's 20 sides. Those are the only ones. Those are the only regular polyhedron, the Platonic solids. This is where it gets a little wacky, and memorization might come into play, but I'm not going to force you guys to memorize anything yet. I will say this this is standard in 8th grade. All 8th graders learn these 3. Okay, so whether you're in geometry or whether you're in my principles of algebra classes, all 8th graders learn cylinders, cones, and spheres. Okay. The surface area is surface area is the 2-dimensional thing. Imagine it this way. You have a box, and you can either fill the box or wrap the box. When you wrap the box with gift wrap, that's the surface area. It goes on the outside and it covers the outside. The volume is what you fill that box with. So as we said the other day when we were talking about area is given to you as a square unit. So, if I'm trying to find the area, I do that times that, and it's whatever unit squared. Volume is a cubic unit because volume has to do with 3 dimensions. Volume, if I were to get gift wrap and wrap it all out, all I have is a plane. It's just a flat thing. However, if I were to crumble the gift wrap up and put it inside a box, now I have 3-dimensional stuff. So surface area is measured in units squared. So if I were asked to find the surface area of that cylinder, or the surface area of that cone, or the surface area of that sphere, I would say whatever units squared, whatever inches squared, whatever yards squared, whatever meters squared. If I were to ask to, if the real life problem were fill up that cylinder with water, how much water do you have? I would say something like 60 inches cubed. Because in order to find volume, you multiply like in this case for cylinder, you multiply radius times height, and that's 3 dimensions being multiplied together. Whereas if you're looking at cylinder, you're multiplying radius times height, or radius times radius for the surface area. So it's 2 things being multiplied together at one time.
Find the volume of a cylinder whose height is 4 centimeters and diameter is 10 centimeters. So I really don't care about the diameter too much. I care about the radius. Remember, radius is half of diameter, so half of 10 is 5. My formula for volume is V equals pi, R for radius squared, H for height. I'm going to plug in pi 5 squared, 4 for height. Throw that into a calculator, and you're going to get pi times 5 squared times 4 That gives us 314.16, we'll say. So V equals 314.16 centimeters cubed.
So let me quick turn up my volume. What did I have to change for that one? I just let it go. What did I have to change for that? Like I couldn't just plug in the numbers that I had. Let me go back. I couldn't just plug in the numbers that I had. I had to turn something into something else. What did I have to do to find the volume? Did I use the number 4? Okay. Did I use the number 10? What did I use instead, Santi, of 10? I did 5 squared. Why didn't I do 10? What does 10 represent in this shape?
The diameter?
The diameter. But I don't, according to all these formulas back here, for volume, for the circular volumes, I have R, and I have R, and I have R, which stands for what? Radius. So that's just something that we have to be very aware of. Every now and then I'll be given a diameter, and I have to take half of that, which gives me the radius. Let's do one more video. Nope. We're just going to get right to it. We're going to find the surface area and volume of each solid to the nearest tenth. What I'm going to do is I'm going to write out the volume formulas for each. Let's just do it actually one at a time. Get a scrap sheet of paper. And the surface area formula for any rectangular prism. And this is, don't memorize it. This is how I memorize it. You have a length, you have a width, and a height. So no memorization is needed. Okay. If I were to do length times width, that's the bottom and the top. That's the ceiling and the floor. So I have 2 of those. This is the surface area, by the way. I have 2 length and heights. And I have 2, what 2 letters didn't I not use twice yet? What 2 letters should I do for 2? 2 what? What do you think? I did 2 LW plus 2 LH. So 2 WH or HW. Very good. For homework. The way I memorize this is, I don't even know if this is the same exact order that the notes that I put in the notes. I don't even know if it's the same exact order. It doesn't even matter. 2 LW plus 2 LH. I've now used L twice, plus 2, and I haven't used H and W twice. So this is the surface area. Nuts. I was hoping I could scooch it over, but I can't. That's the surface area. And who remembers, you should know this, the volume of a rectangular prism? Easy. The easiest formula of all. I'll give you a hint. It rhymes with breadth times breadth times breadth.
Length, width, times height.
Gathered.
I second guess myself.
Don't you dare. So I'm going to let this marinate for 2 minutes. And I want you guys to grab some scrap paper. Notice what I labeled here. And I want you to just do problem 3. Okay, take about 1 minute and just do problem 3, the length, width, and the height. The second part shouldn't take you much longer than 5 seconds. You could actually probably do it in your head. I just did. But you do problem 3. While you do problem 3, I'll write out the formulas for 4. I was going to write out the, I was going to type out the formulas for a sphere, but it's not going to look right. I'll just write it out on the paper instead, or on the Goog instead. Whenever you're done, surface area, and someone should have corrected me. I put S for volume. Why didn't anyone correct me? I blame that on you guys and not on me. I did that on purpose. What was I going to say? In the chat, if you want to start putting in your answers, please do. I dare you. I double dog dare you to do that, please. And by the way, the reason why I have my phone off of silent is because I can do this. You ready? I'm now going to find my surface area of a rectangular prism. It's going to take me like 3 seconds. You ready? What is 2 times 3 times 4 plus 2 times 3 times 3 plus 2 times 3 times 4?
It's 66.
Anybody else get 66? Centimeters squared. And who put the answer to the volume? I guess we'll find out. Siri is not cheating. What is 3 times 4 times 3?
The answer is 36.
36 what? Centimeters cubed. So that's 3. Now, without showing too much work, unmute yourself, or you're better off unmuting yourself. What should I tell Siri to do to find the volume of that sphere over there? You guys are killing me. Killing me. Find the volume of the sphere. What do I say to Siri when I say, "Hey Siri, what is
the volume of a sphere with the radius of 6?
Say that one more time. I'm sorry, I didn't hear you. My volume's actually down low. That's probably why I can't hear you guys that well.
What is the volume to a sphere with the radius of 6?
Oh, that's too easy. That's cheating. That's cheating. Hey Siri, what's 4/3 times pi times 6 to the 3rd power?
The answer is approximately 904.779.
That's not cheating, because that tells me I know what I'm doing. 904. Athena, is that what you didn't sub? Yeah, that's what Athena posted up there. 904.8. So I'll round it there. Very good. 904.8. That's the volume. Somebody asked why it's 4/3. Hold on, I can't multitask. Since sphere is like a perfectly rounded thing, you're kind of like you're taking off like corners of stuff, and after you take off, like if you've ever seen like one of those like wood spinning videos on YouTube, and the guy like whittles down the wood that's spinning, and if you're wondering, like if he takes like a perfect cube and whittles it down and starts hacking away at it to create a sphere, he is getting rid of a perfect number, and that perfect number happens to be 2/3. So, and pi is involved as well. So why it's 4/3? It's just the math makes it that way. And same thing with the surface area. Why is it 4? Why isn't it 5 pi r squared? I don't know. It's just if I were to take like a beach ball and cut it apart into different pieces, it just so happens that the surface area is going to be 4 pi r squared. And if I wanted to find the surface area, what is 4 times pi times 6 squared? What is 4 times pi times 6 squared?
The answer is approximately 452.389.
And that's what Athena said. So I will say S is 452.4 centimeters squared. So the reality is, if you do, I don't remember what the assignment is for tomorrow. I think it's just naming things, because like I'm not going to make you like do like the volume of all of these different shapes, because that's just wacky pants. Although I could, but I'm not wacky pants. It's just naming things tomorrow. How much time do I have? Let's do that word problem, then we'll call it a day. Lamia. Ooh, Lamia is icing cupcakes with a cone-shaped icing bag. That's okay, cone-shaped icing bag. That is 3.5 inches in diameter. I don't care about diameter. What do I care about?
Radius.
So, what is half of 3.5?
It's 1.75.
Sure is. And it has a slant height of 5.3 inches. Slant height. That's a phrase that we haven't gone over in class yet. Slant height is not this height. The slant height is this side right here. That's it tells me how tall it is. Never mind. The regular height is 5. The slant height is 5.3. I thought this was going to be a bad problem. Poop. All right, this isn't bad. Find the volume of the icing that will fill the bag. A, the volume of a cone is 1/3 pi. That's supposed to say 1/3 pi r squared h. That's how you find the volume of a cone. What am I telling Siri to do? 1/3 times pi times what? Come on. Radius squared, which is 1.5 or 75 squared, times 5 or 5.3. What's my height here? What's my height? 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 5 or 5.3? No, 5 is. The height is the straight up and down line. And the straight up and down line is 5. So I'm going to do 1/3 times pi times 1.75 squared times 5. What's 1/3 times pi times 1.75 squared times 5?
The answer is 16.0352.
So we'll leave it at 16. 16 what? 16 inches cubed? Now this is where it gets wacky. You ready? Let's go back. Take me back. The surface area is pi radius L plus pi r squared. What I'm doing to calculate surface area is I'm taking pi RL, which looks like TRL, a popular TV show from the 90s, plus pi r squared. What's pi r squared's area mean? What's the area of a blank is pi r squared? The area of what shape is pi r squared? Silence. 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 Circle. I'm just going to answer for you. So what this question is asking us is the area of a plastic bag used to make the icing bag has no top. Some of you might say no cap, but I'm going to say no top. No top means it's going to be pi RL plus no circle. So the surface area that I care about is pi RL. And that's it. S equals pi RL. Now what's L? L is the slant height. That is my L. That is my L. So I'm going to tell Siri to multiply Pi times 1.75 times 5.3.
That would be about 29.1382.
So 29.1 inches squared. So I think we're going to need a little bit of practice on this, John, because I think there was too much silence for my enjoyment. I'm going to stop recording. Oh yeah, here's the end, which we don't have time to do. Although it's obvious. Although no, it's not. But I'm going to stop recording. I'm going to post the